Welcome back to All This Math. This is Professor Parker, and for this lesson, we're going to talk about some circle geometry. All right, circle geometry, dealing with different aspects of circles and the different features of circles and how to calculate different measurements within circles. That's what we're going to do. Now, in this particular problem, we're dealing with not a full circle, but what we call a semicircle. Right? Semi, prefix semi meaning half. Right? So this is half of a circle. So look at this picture right there. Right? This is half of a circle. Just think of it as like half of a pie or half of a pizza or half of a circular cake or half of some circle that's just randomly drawn, okay? Now, our instructions are to find the area. But remember, we're not finding the area of an entire circle. We're only finding the area of a part of a circle. And in this case, we're finding the area, that part is a half because it's a semicircle, okay? Now, another thing you want to keep in mind is that we want to find two different answers. Right? The answers represent the same value, but they're represented the same, but they're presented the same way, I should say. So in terms of pi and not in terms of pi. All right. Now, typically, most of the time, we give an answer that's not in terms of pi, meaning we take the Greek letter pi, right, and we convert it to an estimate, which is 3.14, right? So we just use the number 3.14, right? But when the answer is in terms of pi, that means our final answer will have the Greek letter pi written in it, which means we don't convert the Greek letter pi to the number 3.14. We don't multiply 3.14 by the other values within the formula. And we end up with an answer that has a number, right, in our typical Arabic numeral system with the Greek letter pi next to it. Almost like in algebra, how you have a coefficient of, let's say 3, and then you have a variable, let's say x. So you would have 3x. Except in this particular case, pi is not a variable because we know what pi is. Pi represents a number, right? And just in case you were wondering, pi is the ratio between the circumference and the diameter of any circle in the universe, all right? So if you take the circumference of any circle, which is the perimeter around the circle, divided by the diameter is the length across the circle that cuts through the center, all the way across from one edge to the other, but it's got to cut through the center. That's a chord. It's a special chord that goes from one end of the circle to the other, and it goes through the center. That, that quotient that you get when you divide the circumference all the way around, divided by the diameter, straight through the middle, right, is going to be equal to pi, or 3.14159257, and it goes on forever and ever. Pi never stops. It's an irrational number. It never stops, and it has no pattern. But anyway, this is how we actually do the problem. If you want to find the area, we first start out with our formula for area. So our formula for area of a circle is pi r squared. Okay? Pi r squared. Now, let me just write that down. So area equals pi times the radius squared. So this will be the formula for the area of an entire circle, a whole circle. But think about it. We're not trying to find the area of a whole circle, right? So what we could do is just find the area of a whole circle. If this were a whole circle, we could imagine that this was a whole circle. And then at the end, we could just divide by 2 or multiply by 1/2 to get our actual area. Or we could use a different formula. We could use a formula from the beginning that incorporates the reality that this is only a semicircle. So we could do this. So I could say area of, put this little symbol here for semicircle, right, is equal to 1/2 times pi r squared. I can also do that, all right? So now, let's take the information that we have. Let's just plug the numbers in, right? Let's first find our answer in terms of pi. So if we want to answer in terms of pi, that means this letter pi right here is not going to change to 3.14. It's going to remain pi. It's just going to be pi, all right? It's not going to change to 3.14. When we find our second answer that's not in terms of pi, then we will convert this to 3.14, all right? So I got my 1/2. And I got my pi, right? Because I'm not changing that. Now R stands for radius. Now, I'm not given the radius from this picture, right? Explicitly, I'm not given, but implicitly, it's there. We can figure it out, right? So, because the radius is the length from the center of a circle to the edge of the circle. The radius goes from the center to the edge. The diameter goes from edge to edge and goes through the center. So that's why the diameter is always double the radius. So that's something for you to memorize if you haven't already. The diameter is always double whatever the radius is. So if you know that, then you also know that the radius is always half of the diameter. The radius will always be half of the diameter, no matter what. The radius is going to be half of the diameter, no matter what. So this is my diameter, 2 feet, from one edge of the circle to the other edge of the circle. And because we know this is a semicircle, then this has to be the diameter, right? Because this has to be like the center point of it. Because if it wasn't, then this wouldn't be a semicircle, because it wouldn't actually be half of the circle, right? But that's given information that I presented in the beginning, that this, in fact, is a semicircle. All right, so the radius is always half of the diameter. And if you know that the diameter is 2, so let's say D equals 2 feet. So therefore the radius is 1 foot, because 1 is half of 2. All right, so we replace the letter R with a 1. Don't forget about the exponent 2. And now we do our calculation. So order of operations, we use the exponent first. 1 squared is just 1. 1 times 1, that's 1. Then we have 1/2 times 1, which is just 1/2. So that leaves us with 1/2 pi, right? 1/2 pi. Now, because our answer is going to be in terms of pi, we want pi in the final answer. So we could leave an answer like that. This could be our final answer. That's one possibility. Or we could rewrite it as pi over 2. Because we can think of pi as a fraction in itself. We can think of pi as pi over 1 and then just multiply horizontally. 1 times pi gives me pi in my numerator. And then this invisible 1 underneath of the pi could be multiplied by the 2 to get 2 in my denominator. Pi over 2. So either of these answers are good. And even if you wanted to like convert 1/2 to a decimal, you could also do that. 0.5 pi. That's another option, you know? So these are all 3 of these are valid answers. They're all valid answers. All 3 of these are valid answers, okay? All right, now, not in terms of pi, meaning we're going to convert, in this step right here, I would have converted this to 3.14, okay? So let's do that. So let's say I got 1/2 times 3.14 times 1 squared. So 1 squared is still 1, and then 1 times, now I could do 1 times 3.14 and then 3.14 times 1/2, which is like saying 3.14 divided by 2. Notice, 1/2 times 3.14 is the same as 3.14 divided by 2. So now I'm gonna try to do this mentally so I don't have to go run and grab my calculator. So if I'm taking half of 3.14, that's not gonna be that bad, because I can just take half of 3, which is 1.5, and then half of 0.14, which is 0.07, because half of 14 is 7, so half of 0.14, or half of 14 cent is 7 cents. So half of 0.14 is 0.07. Half of $3 is $1.50, so that's 1.5. And this is like some of the, math tricks we can use when we have numeracy. We understand how numbers work, right? So 1.5 plus 0.07 is 1.57. Oh, but I forgot something. I should always have units. I forgot to include my units here. So these are not the best answers, right? Because we're dealing in feet. We're dealing in feet and we're dealing with area. We're dealing in feet and we're dealing in area. So area is always has units to the second power. So these should be square feet. So this should be either 1/2 pi square feet, or pi over 2 square feet, or 0.5 pi square feet. So just write feet squared out here, or feet squared out here. All right. So I'm going to say in terms of pi, 0.5 pi, and not in terms of pi, 1.57. I forgot my units again. All right, here we go. 0.5 pi feet squared, or square feet, and not in terms of pi, 1.57 square feet. All right, so this varies from our typical work that we might do in terms of finding the area of a circle, because we're dealing with a semicircle, okay? So all that means is that we just have to take the formula for the area of a circle and just multiply what we find by 1/2. That's all we have to do. So this is how it differed, right? Normal formula for the area of a circle, pi r squared. Formula for the area of a semicircle, remember the prefix semi means 1/2. We're multiplying 1/2 by pi r squared. All right, so So that's pretty much it. Now, I've shown you how to do it. Now, the key is, in order to master this, which I want you to do, I want you to master this, right? Anything that I cover on this channel, on the YouTube channel, which I hope you subscribe to, please subscribe if you haven't already, and also share with other people. I want you to master any of these skills. Now, I can show you how to do it, but the way you master it is by taking what I've shown you and leveraging that, and then going out and doing more and more practice problems. All right? So go get some practice, and I'll catch up with you on the next video. Peace.